and wet locations. So because of that fact, you're going to have to start with the 75 degree column and not the 90 degree column in this install. So you go back.
Going off the Celsius temperatures.
Huh?
Why are we going off the Celsius temperatures and not the Fahrenheit temperatures? Just out of curiosity. And you get some 75 degrees, but that's seasonal.
Because the top of the table is listed in Celsius, and I'm used to the 60, the 75, and the 90. If I changed it, I'd be relearning, and that'd be bad.
Lost all the way.
I mean, it's easy in Celsius in this particular case because it's 60, 75, and 90. If I had to remember it in Fahrenheit and then talk to you about it, it'd be 140, 167, or 194. So, I mean, it's anyway, so we go to step 1 on your ampacity table. The core ampacity for that wire in that install is what?
200.
200. We're not going to be able to use the 225 because of the temperature restriction. All right, so the next step is we have to look at the ambient temperature. The ambient temperature given here is 106 degrees, but at a rooftop, 3.5 inches, we have an adder that we have to put on top of that, and that is what?
40.
You flip back one page to your 31015B3C, and at 3.5 inches, we're on the second row, not the third, and that's 40 degrees. So actually, we have 146 degree temperature. Back one more page to 31015B2A. Under, and here I revert back to Fahrenheit, so I understand it's kind of non-congruous, but 146 then falls under the 141 through 149. I'm still going to the 75 degree column in the center, which would be 47% derating. So in essence, I have 47 amps for each one of the 200 amps, so I've got 94 total amps, right? If I take 200 amps times 0.47, I end up with 94 amps. So that is the derating all the way down from step 1, step 2, step 2A. Finally, don't forget step 3, which is the number of current carrying conductors. You have 6 of them there, right? 6 current carrying conductors has a derating of what? 80%, that's correct. So we have an 80% derating of the 94 amps, and that gives you a final derating value of 75 point what? 2, so 75 amps. So just because of that rooftop install, you started with a 200 amp wire and ended up with a 75 amp capacity. Now you see why rooftop installs are hopefully going to be kind of a thing in the past. Well, yeah, the calculation's complicated, but the expense of running it rooftop because of the derating has really gotten to be a big deal. And we had a situation not too long ago. In fact, that same one I was telling you all about with the panel, we ended up having to run a new circuit. Well, the distribution point, if we'd have had to run new feeders, we would have had to go across the rooftop. And so instead of having aluminum, I think they fed with aluminum number 4, I think it was the SER cable. So we would have had, for a 100 amp service on a rooftop like that in aluminum, it would have been just some ungodly size, and the expense and the conduit would have just been too much. All right, so that finishes that one. How'd you guys do on the box fill? On box fill, real quickly, what we're seeing more than anything else is mostly your junction box sizing. And we're seeing them fairly frequently, but most of what we're seeing is like the way the question is worded gives you a clue that it's a U box or a U pull. Okay, they have 4 4-inch, I believe, 4 4-inch conduits coming in either at the bottom and leaving out of the back, something of that nature. Does that sound familiar? And so on a junction box, here's your rough opening here. All right, so, well, that's terrible. All right, what the hell is that? The way we size that is based on the raceways coming in one side, right? So if these are all, I can't remember if it was 2 inch or 4 inch. Do y'all remember? I think it was 2 inch, wasn't it? 4 2 inches? I think it was 4 2-inch conduits. So what's the rule on sizing junction boxes? Where is the article that we deal with on it?
Outlet.
Junction box sizing.
Junction box.
The way it's worded tells you that it comes in the bottom and it exits out the back around the corner of a building, or they give you some kind of indication that you're going, you know, on the back part here.
8 times.
It is, it's 8 times, right? It's 314.28, 24, 28. So 314.28 on page 183. So the way we do this is we're talking about from the side that it enters to the opposite side is the measurement that we're dealing with in that section. So if you have the largest raceway, and it will be multiplied times 6 times, so you're going to take 6 times 2, which equals 12, correct? And then you're going to add the sum of all of the raceways in the same row on that side. So it's 12, 13, 14, 15, 16, 17, 18. 18 inches is going to be the minimum distance from here to here on that box. Okay? The depth as well, if you have 4 of them going out of the back, it's the same measurement. It's from the opposite wall, so you have to have from the back part to the front part the same steps. So if you have an 18-inch height and you have the exact same stuff on that side, it's 6 times 2 plus the sum of 2, 4, 6, which is 18 inches. So you would have an 18-inch depth as well. This would be an 18 by 18 by 18 most likely. I don't think you can get any kind of, unless you custom manufacture them. So by default, that's probably going to be 18 inches as well. But I think all they ask you for is just the height, if I'm not mistaken. Either way, straight boxes are going to be 8 times the largest raceway in a row. Excuse me, 8 times the metric designator, the largest raceway, period. And that's the length of the box, or the conduit body. And then they have a few other rules that kind of come and go in there, and we'll come back and highlight some of them in a minute. And then for the masters, make sure that you remember the 1,000 volt rated is in a different category. Any questions on that? No? The other items are going to be box fill. Have you seen any box fill? Were there any box fill questions? Number of conductors and devices and that kind of thing? Real quickly on box fill. Box fill is calculated based on a nod to both the physical and the thermal properties. Okay? You want to make sure that your junction box is large enough that whatever device you have and whatever wire and splices you have will fit in neatly without damaging them, and also so they'll have enough air to keep the thermal buildup clear. So we have 2 tables, 314.16a, and then the B is the air volume allowance, and it's all based on a wire size. Wire size and wire count. So look at that page real quick. You'll see the first table is your standard table that has all of your manufactured sizes by their cubic inch air space. It's going to be 314.16a on page 179. And at the very bottom down there you see the smaller chart, and that's your cubic inch air volume by conductor size and by count. Okay? So I will tell you to always make a chart when you're doing any kind of box count, okay? Because 9 times out of 10 when you get done, your answer is going to be different than what they have listed for your answers. And it's only because I'm telling you box fill is the single most misunderstood or misused or unpracticed exercise out there. Out of all the classes that I have, the one single question that I've had that I can tell you maybe 3 guys out of 500 have gotten is box fill. So I know from experience that for whatever reason it's just a tough subject. So if you do an actual chart, what will happen is that when you go back and try to figure out where you went wrong, you'll have all your hash marks and everything kind of laid down on your scratch paper, and it'll be easier and faster than to go back and correct yourself. Okay? If you're just trying to do it in your head, you're going to do it in your head said 4 or 5 times, I promise. Okay? So just make yourself a little chart, write the wire sizes, all the wire sizes present in the box. Doesn't matter what they go to or what they are, just write them down. And then go back and make your tick marks next to each size as you're counting them off on the question. And add in your cubic inch air volume, do the math, and plug it all in. So, the way we count them is on conductors. If it starts outside the box and terminates in the box, it counts as 1. Okay? If it comes in and passes through at the bottom, only 1 count. If it comes in and leaves a loop of 12 inches or more, we have to count it as 2. And why is that? Well, an in and out only counts once, right? And into a splice and out to, from the splice back out, that's actually a 2 count, right?
Loop 12 inches or more.
Now,
In and out.
remember, what's the rule for the length of free conductors?
6 inches.
6 inches, right? So if you're leaving a loop at 12 inches, that means that there's probably going to be a
6
termination at some point in the future. So because of that, we want to make sure that we're taking that into account. So rather than a pass-through, which counts as 1, if you leave a loop, you have to count it as twice. Same thing with terminations, count as twice. Then devices count as 2. With devices, we count those as the largest conductor connected to them. And a device is going to be a toggle or a outlet receptacle, be it Decora, duplex, uniplex, any kind of device. It's counted by the yoke. So let's say you had 3 toggles in a switch bank. You'd have 2 wires counted at, let's say, 14 gauge, because that's what you got terminated to. So you'd have a total of 6 number 14s for those 3 toggle switches. Huh? At 14 it's 2.0, yeah. So you'd have a total of 12 cubic inch. You'd have, how many did I say? There was 3, so it'd be 6 times 2 would be 12. And then cable clamps, studs, or hickeys. Cable clamps are, the little metal clamps in the back of the metal boxes for Romex to go in, or UF cable, and you just screw them down. They look kind of like a little double clamp there with a screw in the middle. Studs or hickeys, those are type fixture studs or fixture hickeys or anything of that nature, or hickeys that hold the box to a strap across the top. And all of we also have the cable clamps, right? So we're going to count one number 10 for the cable clamps because that's the largest conductor present in the box.
10 grams.
And then finally, this number 10 ground right here, that number 10, we're going to count it, right? But when we count that, it's going to eliminate these 3 right here because those are also the same animal, right? We count all grounds as 1 count of the largest of their own size. So we'll have 1 more count on the number 10, and that takes care of all the grounds. Then we look at the number 12s. We have 2 receptacles, we have number 12 jumpers, and we have 12 ungrounded conductors. Not a neutral in the whole damn box.
8. That's 8.
So number 4, we have 4 number 12s there for the ungrounded. We have 2 receptacles. Each receptacle counts as a 2 count, so I actually have 4 there. And the jumpers are number 12, so I'm going to use that to count the devices as 1, 2, 3, 4. And what else? Am I forgetting anything?
That's it.
That's it, right? We counted all the grounds, got the cable clamps, we've got the jumpers, don't count. We just use them to size the count for the device. So 6 times 2.5 and 8 times 2.25. What do you get?
15 and 18.
And there you go. Did you get that one right?
Yes, sir.
Man, I did the exercise on the wrong one, huh? All right, number 6.
Yeah, if you'd have done it on the other one, I'd have got the sticky, because I already had the answer from the last class.
All right, number 6.
I
Calculate
understood
demand
that.
load for ranges. So the first thing you do when you have multiple ranges is you want to look and see where do they fall. What categories are they? All right, excuse me, what columns are they? So on page 66, under 220.55, where do those ranges fall? And as range question goes, this is fairly easy because they all happen to fall under the same column, and that's going to be column B. So we're going to add the nameplates together. What did you, just out of curiosity, what did you get for the total connected load for that group of ranges? Somebody throw me a number.
27.5.
27.5. Anybody get anything different? Did anybody get anything different when you added the nameplates together? be careful because a lot of guys, they'll do questions just like that where you have the number 2. That's actually 2 8 kW ranges, and a lot of guys will add 6, 8, and 5.5, and they count it as 3 ranges. They do that on motor questions, range questions, quite often where they'll write the word 1, O-N-E, 6 kW range, and they'll put the 2 in parentheses like that, and then they'll give you a single 5.5, and your eye sometimes just kind of glances right over the 2. Okay. It's just, like I said, they're just trying to keep you at a pretty even pace on it. So your total value connected load is 6 plus 16 plus 5.5, that comes up to 27.5. What is the demand derating factor? How much?
50%.
So 50%. Does everybody see where that comes from? Column B, 4 appliances. On page 66, under column B. So you identify that all of these are in the same column, and that's B.
Yeah.
Then you identify that there's 4 of them. You add up the total nameplate value for the total connected load, and then the demand factor from the table is 50% for 4 of them under B. 50%.
Yeah, 50%, so it's be 13.75.
So that'd be correct. It'd be 13.75 kW. Okay? Did anybody not get that one? If you didn't, don't feel bad. I mean, ranges are probably one of the second area that people struggle with on a lot. Number 7, you guys did that one yesterday, so what'd you come up with on it? Right. You did the 1 over R1 plus 1 over R2 plus 1 over R3. When you were done there, you just put in your R values, which was 20, 30, and 50. That gave you 0.05, 0.033, 0.02. So all those added together then become 0.103. That divided into 1 becomes 9.7 ohms. And that's the total ohms for that branch circuit. Coming over here and putting it into EIR, you plug this in at 9.7, this in at 120, and the math on it is 12.4. All right, so the next one is going to be bank at 45,000 square feet.
Thank you, sir.
You're welcome.
Sorry, I'm late.
No problem. You didn't miss anything. I just didn't want to get into the motors until you got here. What about this other guy? I wonder if he's going to make it or not. All right, 45,000 square feet, 265 general purpose receptacle. What is the total demand on the service? Did anybody get that? Did you get it? All right, so anytime you have a commercial building, you're going to have to treat the lighting receptacle load separately. We're going to just blow right through this one because I don't want it. 45,000 square feet. A bank is calculated at 3.5 VA per square foot. It would be considered a continuous duty application, so I would multiply the lighting times 125%. I'm going to do that on the calculator and give you the value real quick. It's what?
1968.75.
1968875?
1968.75.
1968. No, it's not 1968. Well, what is it?
That's 15750.
Oh, 157. That's we gotta be the 125%.
Times 125, is it? 1968.
1968 is right. 1968. What was it?
1968. 1968.75.
There we go.
6875.
Yeah, you were missing a
Yeah, I had it pointed.
little decimal in there. All right, so 196,875. That's based on 45,000 times 3.5, which gives you the, well, what is it? sure one, yeah,
15750.
1575, 00. And then you want to increase that by 25% for the continuous duty. And that is your general lighting load in a nutshell. Nothing else to do. There's no derating in the bank on the lighting, so you're finished. Now, when you do your general purpose receptacles, there's two different sections that you have to calculate them at, right? And then take the larger of the two. What two sections are we dealing with? 220.14 what? What do I use to calculate a receptacle load? What value?
180 VA.
180 VA, right? So I would take the given known receptacle is 265 times 180 VA, and that's under section I, right?
Yep.
And then I have a second calculation if I'm dealing with a bank or an office building, and that's under note K2, and that's what? What's note K2 say?
11.
In banks or office buildings, the receptacle load shall be calculated to be larger, the larger of one or two.
And note 1 is basically calculated under I. Note 2 is the square foot times an additional 1 VA per square foot. So, note I gives me what for a value?
47.
47,700.
Is it 700 or 800?
Yeah, 7.
Note K2 would give me 45,000. The larger of the two is obviously going to be I, so that's going to be the section that we take. Okay?
47?
Huh?
You take it 47?
Yeah, because it's the larger between the two, that's right. So, if the square footage had been 48,000 instead of 45,000, then I'd have had to use note K1 or K2 instead of note I. Take the larger of the two. Now, if I'm under note I am allowed to derate the receptacle load. Take the first 10,000 at 100%.
37,700 at 50%.
37,700 at 50%.
Then add the 10,000 back.
What is that?
18,850.
18,850. Add the 10,000 back. So I add to this value here 28,856. That's the total load on that service based on the lighting and the receptacle power. Just remember, if you're dealing with a commercial building, you're going to have to treat the lighting and receptacle power separately. All right, the Raceway PVC, 8 250 KC mil XHHWs and a single 4-aught THHN. What size PVC did you guys come up with?
3.5.
3 and 3.5.
3.5.
All right, so what's your math on a, first of all, where do you find the insulation value of a wire? What table?
Table 8.
Chapter 9, but not
Chapter
table 8. Chapter 9, table 5, right? So in this case, we're going to start with table 5 with all of our conductors. We have 8 250 KC mil, XHHW, and those have a value of 0.3904 each times 8 gives you what?
3.1232.
Okay, so that's the group of number 8 XHHW under table 5.
Yes.
Next one, we have one additional 4-aught THHN, which is a little different.
That's a 3237.
And
0.32.
0.3237, and that's the one 4-aught, which, by the way, I can tell you right now that'd be an illegal installation if that PVC was going to be, installed in the ground, because THHN is not a wet-rated location conductor. But regardless of that, 4-aught, a single one of those is going to be 0.3237. We're going to add those two together.
3.4469.
So then go back to table 4, find the PVC Raceway. They don't tell you whether it's Schedule 40 or Schedule 80, so I'm going to err to the side of Schedule 40 because it's the more common one. However, either one you choose, you're going to have the same answer, because even though the diameters on the interior are a little different, they're not different enough that it would give you a different answer. I don't believe. I better double check that while I'm saying that. The majority of the PVC differences are so small on the Schedule 40 to the Schedule 80 on the interior that your Schedule 80 is on the bottom of 714 and Schedule 40 is on the top of the next page, 715. And we need a 40% fill on the far right hand side, just big enough to be larger than 3.4469. So that would be 3.5. Now if we look on Schedule 80,